Today we are going to learn about the hydrometer test, which is used to find out the particle size of silt and clay, the percentage of silt and clay. So let's start. Here you can see the figure of the hydrometer. See here, in hydrometer there are given some readings on the upper level of tube, which is given as density in gram per milliliter. Here is the density of distilled water, fresh water, brackish water, sea water and hypersaline water. These are the values given. Then in the bottom there is a weight which is very prescribed for these particular densities, and in between there is a glass bulb. Here the hydrometer analysis is carried out in two stages. First one is calibration of hydrometer. Another one is sedimentation analysis. Then here is the calibration of hydrometer. In hydrometer test, this is one jar which has AA and BB line. The distance between AA and BB line is HE. After injecting a hydrometer, the level of AA and AB will be increased. The difference between AA line and A1 line is considered as VH upon A. The difference between BB and B1 line is considered as VH upon 2A. Here, the distance between B1 line to the top of the bulb is considered as H2, and from that distance to the RH point is considered as a capital H. Here is the basic calibration of this hydrometer. The calibration of hydrometer for the effective height is given as HE is equal to H plus small h by 2 plus VH divided by 2A bracket close minus VH upon A, so that the effective height will become H plus small h by 2 minus VH over A. Here A is considered as the area of a steam or graduate. RH is considered as hydrometer reading. HE is obviously effective height. Capital H is considered as depth of steam up to the hydrometer reading. VH is considered as volume of hydrometer in cc. Now we can understand the correction of hydrometer. Here, to calibration of the hydrometer, we can put one figure which is of abscissa of height of correct readings to the hydrometer readings. Here, hydrometer is immersed in the soil suspension. Hydrometer readings are noted at different time intervals. Effective height values are calculated for corresponding H values. A plot of effective height versus hydrometer reading is used as the calibration chart. Note that calibration of hydrometer is done only once. The same chart can be used for any n number of the trials. Now jump to the test procedure. First, 100 ml of soil suspension is prepared by mixing about 12 to 30 gram of soil with dispersing agents such as sodium hexametaphosphate, which is of 33 gram, and sodium carbonate of 7 gram plus distilled water. Now the 100 ml of soil suspension is added with 900 ml of water and is poured in the jar. The suspension is mixed thoroughly and the hydrometer is immersed in the jar. Then after, hydrometer readings are noted at a different interval of time. The corrected height is taken from the calibration chart as we understand earlier. The diameter of the particle is determined by following equation. Capital D is equal to under root 18 nu divided by gamma s minus gamma w into He divided by small t, where D is equal to diameter of soil particles, capital H is equal to viscosity of water, He obviously as effective height, small t is a time in seconds, gamma s is equal to unit weight of solids, gamma w is equal to unit weight of water. Percentage final is obtained from the following equation. Capital N is equal to into bracket capital G divided by capital G minus 1 bracket close RC divided by WS into 100, where capital N is equal to percentage of fines, where G is equal to specific gravity of soil solids. RC is corrected reading from hydrometer and Ws is equal to weight of solid. Now, correction for hydrometer reading. First one is correction for meniscus, which is denoted as Cm. Correction for meniscus is nothing but the subtraction of mu minus m1, where the mu is upper meniscus and ml is lower meniscus. Here from the figure you can understand about the meniscus. A meniscus is a phenomena which can occur due to the frictional boundary of jar, either it is glass or metal, to the fluid. Due to the frictional forces, the fluid will become stick to this glass so that it will move into the upward direction and make some concave slope. So while you are watching into the tube, you can see a different reading, one difference of 1 to 2 mm. So we have to correct it. How can we get corrected reading? Simple. The difference between this will give a correct reading, so that correction of meniscus will be mu minus m1. Here the correction for meniscus is always positive because upper meniscus shows lesser value than actual. Now correction for temperature, which is denoted by Ct. More temperature than standard temperature is 27 degree. Less will be viscosity. Hydrometer reading will be less than actual and hence correction will be positive. Lesser the temperature than standard temperature 27 degrees, more will be viscosity. Hydrometer reading will more than actual, and hence correction will be negative. The third one is correction for dispersing agent, which is denoted by CD. Addition of dispersing agent increase net density of the sample. This causes more value than the actual. Hence, the correction for dispersing agent will be always be negative. The total correction is given by RC is equal to Cm plus or minus Ct minus Cd. Where Cm is correction for meniscus, Ct is correction for temperature, and Cd is the correction for dispersing agent. Now, to find out the bulk density of soil at the in situ site, we can use the instrument named a core cutter. So let's take a look for the core cutter method. In core cutter method, we have to use three specimens which are given in the figure. A first one is considered as a rammer. This is the rammer. Another one is considered as a core, which is nothing but a cylindrical tube. Another one is collar. Collar has a sharp end edges on one side. Now take a look for the core cutter method. The core cutter method is used for cohesive soil in which core cutter can be easily penetrated. Take an empty weight of core without collar and consider it as a W1. Penetrate the core into the earth using rammer. After chipping off extra soil, note down weight of core along with the soil and give it a name W2. Determine moisture content of the soil using oven dry method. The oven dry method we already understand earlier. A bulk unit weight and a dry unit weight can be determined as follows. A calculation of in situ density. Measure the volume of core. In situ density is W2 is equal to W1 divided by V. V is nothing but a volume of sample. Dry density is, obviously we know the relation between bulk density and dry density. So the dry density equation is gamma B over 1 plus W. Small w is water content. Moisture content can be calculated by oven dry method. Is taken here in the percentage. If the moisture content is taken as 15%, then take the value of W is 0.15 because 15% it's a percentage value. We have to compute it into the numbers or rate. Into the value. So that we have to put 0.15 instead of 15. Now, in situ density by sand replacement method. In sand replacement method, there are this type of cylindrical tube and a square plate with a circular hole into the center. This test is done in two steps. Calibration of a container and second one is determination of in situ density of soil. Sand is filled in the sand pouring cylinder, and the weight is taken with a closed shutter and give it name as W1. The sand pouring cylinder is placed on a smooth glass plate and the sand is allowed to run out of cone. Weight the sand pouring cylinder after running sand into the cone and note down it as W2. A sand pouring cylinder is refilled and placed on calibrating container and sand is allowed to run out. The weight of sand pouring cylinder is noted after running sand into the calibrating container. Note down it as W3. Weight of sand in cone is equal to W1 minus W2. Weight of sand in calibrating container is equal to W1 minus W3 plus W weight of sand in cone, which is W cone. Volume of calibrating container is determined by V into VCC. The unit weight of sand is gamma sand is equal to WCC divided by VCC. From this equation we can find out the main VCC, which is going to be WCC divided by density of sand. A sand pouring cylinder which stand up to W1 is taken to the field where bulk unit weight is required. The surface is cleaned and leveled. The tray with central hole is placed into the position. A hole of approximately same size as calibrating container is dug into the ground. Now, the removed soil is collected onto the side of tray and its weight is noted down as W soil. The sand pouring cylinder is placed on the hole and sand is allowed to run into the hole. Weight of sand pouring cylinder is noted as W4. Weight of sand into the hole W5 is given as W1 minus W4 plus W cone. Volume of the hole, which is noted by volume of soil, is equal to weight of sand in hole, which is noted by W5 divided by density of sand. Here, the in situ density of soil is governed by the density equation, which is density is equal to weight over volume. Here we can use the weight of soil divided by volume of soil. So guys, today we learn about hydrometer test, a core cutter method, and the sand replacement method. Hope guys you can understand this topic. So goodbye for now. See you into the next lecture. Thank you.